Hello everyone. Today we will create a procedural projectile arrow system using Houdini's Vex. So we are going to be focusing on bezier curve trajectory planning. So this method gives very good control over the trajectory or the flight path. We'll create something like this. So in this system, we will be able to select our own custom start point where the arrow should start and the end point also. And we will control the path using another third point called it's called control point. You'll see what I mean. Let's create a geometry and we will add 3 points. Instead of just for visualization, I'll add three primitive spheres. Primitive, and it will be like 4 meters on the x-axis. We'll call this start point, and we'll create one more sphere. We'll call it control point, and this for now we'll keep it at the origin, and we'll also create one more point. So this will be the end point. So this is where the projectile will end up. So we have like 3 path, and this will be at -4 in its axis. So if we merge these 3, it looks something like this. So this is the start point, this is the control point, and this is the end point. Okay. We'll connect all these 3 to a angle. To the first, second, and third input. So the first thing we will do is we will define all these 3 start point, control point, and the end point's position as a variable. Vector, we'll call it start pos. So that will be the first input. So v at p. Then the control point, we'll call it control pos. So this will be the first input. And the third one will be the end pose. This will be the second input, the position from the second input. Okay. So we'll be using the same equation which is used to create a bezier curve in computer graphics to create this projectile path. So this is the equation to figure out the path of a bezier curve. So in this equation, this t is the variable. So by adjusting this t parameter, we can animate the arrow along the curve. So we'll create a new variable called t. So this t will be a float variable. And we will call it time. And we'll create a separate channel for it. So we'll just replicate this equation in Houdini. And we will assign it to position. We get p equals 1 minus t square. So 1 minus t into 1 minus t into start position, start pose, plus 2 into 1 minus t into t into control pose plus t square. So t into t into end pose, the end position. Okay. Now we'll create this variable for t. And when we adjust it from 0 to 1, you can see the point basically moves from start position to end position. See this? But it is not a projectile path. It is a straight position, straight path. So that is where this control point comes in. So we can adjust this control path to get the curved path. So we'll reference these 3 points, and now we'll move this control point little bit upwards. Now if you just scroll this, like we are seeing that the sphere is like kind of following a curved path. You can think of this control point like a magnetic pull, so it influences the curve's direction. Now if you, like for example, lift it more, the ball is going to have like more curved path, like it goes up and then it comes down. So by adjusting the control point's position, we can decide on the curve shape. So let's keep the control point something like this. We'll create a simple arrow. We'll put a line. And we'll put a match size. So the line like kind of like comes in between the origin. And we will blast the point 1. And we will copy a sphere to it. And to the wire, we'll add a poly wire. I mean to the arrow. We'll keep a low radius value. And we will merge it with the sphere. We should select points from here and we'll make the sphere smaller. And that's it. Like now we can copy to the point. But the orientation is like not proper. So we'll have to calculate the orientation. The normal direction is where this arrow points towards. So we have to calculate two normals at the beginning. So when it starts from the start point, it should be like kind of pointing upwards towards the control point. And when it like kind of reaches the end point, it should be looking towards the end point. So that is how the arrow works. Like initially it is like looking at that control point, then slowly it descends and it turns towards the end point. So here we need to calculate uh, two normals. Okay. Also, we'll change the line's direction from Y to Z origin. Okay. So the first normal that we are going to create is the start normal. Okay. So the start normal is the direction from the start point to the control point. So from start to the control point. So this starting normal vector should be pointing towards the control point. So we'll create a vector. We'll call it start normal equals to start point, start pose minus control pose. Just for checking, we will assign it to the normal. Yeah, you can see the arrow is like kind of pointing towards the control point. But once it keeps on traveling, it should slowly start to look at the end point. So we'll create one more normal also. We'll call it vector into normal. So this normal will be like between the control position and the endpoint. So control pose minus end pose. Now we will assign this normal and see what it is happening. End normal. You can see the arrow is like kind of pointing downward. So kind of like from here to here, like control position to the end position. But we actually need to have both the normals. At the beginning, it will be like from here to here. It will be like pointing towards the control point. Then slowly it changes to towards the end position. So what we will do is we'll lerp it. Okay, lerp start normal and in normal, and the bias will be T. So now when we animate, you can see the orientation of the arrow is like proper. The normal is like kind of linearly interpolating between this position to, I mean this direction to the endpoint's direction. Okay, and what we can do is like just we can animate this time automatically using this expression fit dollar frame, I mean at frame from 1 to 30, like 1 second to reach the destination, and we will keep the value 0 to 1. Yeah, now if you play, it should animate. So we created a very simple projectile system, and if you like this tutorial, you can subscribe to my Patreon, and you can also download all the hip files for all of my tutorials in the Patreon, or else you can just subscribe to my YouTube channel. And if you like the video, please leave a like, and I will see you all on the next tutorial. Thank you.